So to try some examples from today's presentation, I'm already creating a new project and naming it week 14. So if in case we need to try something out, we will have a placeholder for that. All right, so this is our project, and we can do our usual preparations to get started with the demo code. And so today's topics, if you go to the outline, today's topics are going to be, there are two things to cover, binary files and random access files. So let's start with binary files. And speaking of access to binary files, we're going to go back to this class hierarchy just to highlight which of these classes of the Java API library we're using. So I'm just going to copy this image and open it in some kind of a Scratchpad environment where I can paste this in and go back if I have to go back and talk about specific classes. All right, so this is the hierarchy of classes which generally speaking are dealing with I/O. And so today we're going to cover and we're going to talk about binary files. So the binary file stores the data in form of bytes which contain raw data. So of course, when you create an integer variable or double variable or character variable, you know that some memory is allocated. And so the idea of a binary file is that it's the binary file info gets saved in the file so that generally speaking it won't be readable. As we practice some of these facilities, we will try opening these files in the text editor and just see if we can recognize anything at all that would be still readable. So we'll try that. And of course, every single type of primitive data type will have its own internal storage. For instance, double will be, as you know, 8 bytes in size, but its internal format, you need to look up the standard to realize which one is the fractional part, which one is the whole part of the number, and it's going to be a proprietary format, even because we also have issues with Indianness of memory, which is the order of these bytes. And so we will talk about the possibilities here, what can be done in the portable format, and what things to beware of. We will talk about that. All right, so this is yet another view of the hierarchy of classes that we're going to use today. And we are going to be using basically the input stream and output stream hierarchies, which are also visible on this diagram right here. There's an output stream right here, and there's input stream. So I think that this is kind of like a little friendlier format than the other one, but nevertheless, this is many of these classes we're going to have to discuss today, and we'll see where it takes us. And this is going to be part of our final exam questions. Obviously, you can practice and learn answers from the practice session, but we need to cover the entire set of topics here. So first thing, the very important thing is this data output stream, which is basically the data stands here, the name data in the data output stream stands for binary output. Binary output means that no attempts to convert from internal format to a text form will be attempted. Instead, some kind of raw data will be picked up from memory and stored inside the file. All right, so the data output stream implements data output interface. In the hierarchy, you can see here that the data output stream derives itself from the file output stream, and at the top of the hierarchy we have the output stream. So we essentially stack up on the functionality of these classes when we work with the specific type of output that deals with binary files. Now, the data output stream writes primitive data types to an output stream in a portable way. Now, what is the issue of portability? Well, maybe I can go and show you something here. If you store 1 byte in memory, like 1 byte right here, 1 byte we could draw like a little square. If you want to store in one integer in memory, most likely it's going to take like 4 times the byte size, which is like this is altogether 32 bits, right, or 4 bytes in memory. Now this is in memory, and each byte has actually an individual address, right? So the address of this byte can be 1000, the address of this byte could be 1001, right? This could be 1002, this can be 1003, as an example, some arbitrary addresses in memory. Now, here's the picture of memory, right? Here's the picture of memory. When these integers and bytes and characters and other primitive types are processed by the CPU, it happens inside the CPU, right? So we need to go here and draw the boundary and say, okay, these are the boundaries of our CPU. So this is our chip right there. Inside the chip, we deal with these things. So this is inside the CPU. We can do math. We can move these in and out of memory. But when it's wired into memory, it can be wired in 2 ways. The first option would be to say, all right, if we want to store bytes in memory, so similarly we can picture 4 bytes in memory, and then this byte can be physically saved here. This byte can be physically saved over here, and this byte can be physically saved over here, and this one can be saved over here. So this is one version of saving the data, right? So if somehow I was able to store here things such as AA, BB, CC, and DD using hexadecimal notation, then the type of storage would be AA, BB, CC, and DD. Now, assuming that this is the lowest byte in this integer, right, you can see that the lowest byte actually appears to be in the highest, in the lowest memory address. So this is memory address 1000, 1001, 1002, and 1003. Okay. We could wire it up differently, okay? We could actually take the eraser, right? And we can just say, wait a minute, we could wire it differently, right? So we could, what we could do, we could wire it differently. And we could wire it this way, so that A goes here, B goes over here, C goes here, and D goes into this line. So this way, if we stored it this way, it would actually be in opposite order. It could be DD, BB, AA, and this would be CC, BB, and AA type of order. Exactly the opposite of the other one. So the two types of connections that connect the CPU to memory are called the Little Indian format and Big Indian format. Okay, and so therefore, if you use one architecture that wires itself this way, and the other architecture that wires itself the other way, unfortunately, the bytes will be reversed, and so your integer value will change and will no longer be the same integer. Because if you store this in memory and then you store this on disk, and then you bring your file back to memory and you load it into the CPU, you may be on a different architecture, on a different computer, like compared Intel chip to ARM chip, you could be reversing these bytes. So that's why Java library says that if you're using data output stream, regardless of the Indianness of your machine, your Java virtual machine will be able to both save and load the data in a portable way. So you don't have to worry about the Indianness of your machine, and you don't have to worry about this architectural storage of multi-byte values in memory. Okay, so this is very important, and this is something that you have to worry about if you dealing with binary files, right? So that's why perhaps Java designers decided to add those special classes that allow you to deal with the storage types of arithmetic values which are multi-byte in size in a portable way. So you don't have to worry about the order. Magically, the library will be processing everything very properly. Okay, so typically the Intel machines are little Indian machines. The all transmission on the network is in big Indian format. So there are different standards for different environments, and likewise on your Android tablet, same thing. Most likely the byte ordering will be different compared to the internal byte ordering used on traditional PC, IBM PC style desktop or laptop. So anyway, we need to be aware of how to construct everything properly. And so let's take a look at the example, and we're going to do next segment for that.